Welcome to NCIX Tech Tips. Today I'm going to be showing you guys how to build your very own Shuttle XPC. So a Shuttle XPC is made by Shuttle, and what it is a small form factor computer. This is a bare bones. Bare bones means it includes a case, motherboard, and power supply. And what that means is that you can take whatever components you want. You can take a Core i3 and a little bit of RAM. You can make a media PC. You can take a Core i5, a decent graphics card. You can make a little small form factor gaming PC. The choice is completely up to you. The first step is to use the thumb screws at the back to take the cover off of the XPC bare bones. Now once we get the cover off, you can see that the Shuttle XPC has actually been pre-assembled to a certain extent. So all of the cabling is pretty much where you need it, including SATA cables that are beautifully routed from the bottom up to the top of the case where we're going to mount the drives. The power supply, the 80 plus bronze power supply that is capable of 350 watts of output, is pre-installed, and you can also see that the CPU heatsink as well as the power cables for the motherboard are pre-installed as well. So some disassembly is required before we actually get started here. I removed 2 screws from the top, and the first piece I'm going to take out is the drive cage. So I can mount my hard drives and optical drive in here, and then I can put the whole assembled unit back in. This also gives me more room to work to install the CPU and RAM and all of the power cables. Now the CPU cooler that Shuttle uses is a custom design just for them, and it's actually really cool. So in much the same way that those pre-filled liquid cooling systems cool your CPU and exhaust hot air from your case, so does this. So you've got a little heatsink here with 3 heat pipes leading up to, and I already undid these 4 screws around it, leading up to a little radiator style thing that has an 80mm fan built into it, and the whole unit comes out in one piece, just like this. So that unit cools the CPU and carries the heat directly to where it will be exhausted out the back of the case through these exhaust vents. This gives us access to the CPU socket right here, where we will be installing, as per the manufacturer instructions, no CPUs over 95 watts. So we're going to be using a Core i3. CPU installation is done in the normal way, aligning the tabs on the side of the socket with the notches on the side of the CPU. You drop the retention bracket, pull the arm down, and your CPU is installed. Then you apply a small amount of thermal compound, about the size of an uncooked grain of rice, to the middle of the CPU, and now it is time to reinstall the CPU cooler. So for the next step, we'll be installing some Mushkin enhanced stiletto RAM. This is a fairly standard installation procedure. With LGA 1155, it doesn't matter. There's no primary sockets or secondary sockets, so you can populate whichever ones are most convenient. As a general rule, I like to populate the ones further away from the CPU socket first, because it gives the CPU socket a little bit more room to breathe. We're going to be using a 2.5-inch SSD as our boot drive. This is an Intel 510 series performance SATA 3 6 gigabit per second hard drive. Well, it's an SSD drive. And I'm going to go ahead and use the included mounting kit. This is a 2.5-inch to 3.5-inch adapter that comes with the drive. Now, this case does not natively support 2.5-inch drives, but with this kit, I can go ahead, mount the drive here, and then I install the drive on its rails inside the Shuttle case, just like this. Now our SSD is mounted quite securely here. It's not going anywhere. Next, we have the optical drive. Now the optical drive has a number of different alignments for the holes on the side. Easiest way to get it installed correctly is to go ahead and pop out the bezel, put this back inside. There we go, that is aligned correctly. And then slide the drive in from the front until it is flush, and then use that as a reference point for where to put the screws in on the side of the drive. So now we reinstall the drive cages, and you can see our drives now have their SATA interfaces pretty much perfectly aligned at the back. So we're going to take these pre-managed SATA cables, and these are both hooked up to the SATA 3 6 gigabit per second controller that is built into the Shuttle H67 motherboard. And we're going to go ahead and plug the data connections into each of our drives, and they fit perfectly. Check that out. It's almost like it's designed to work like that. And then next, we have the SATA power cables, which are also designed to fit in here just right. Let me just see if I can see which one is a touch longer. And that's the one that is designed to go right there. So we plug the bottom SATA data into the bottom drive, and then the next one into the top drive. So the next step, now we could be finished now, and we could use the onboard video that's included on the Core i3, but I'm going to remove the PCI brackets at the back. You can see we do have a full PCIe 16X slot here, as well as a PCIe 1X slot. That means we have full support for dual slot graphics card. Also, please note, there's a couple more SATA ports here. Should you desire more internal storage, remember you've got another hard drive port here, or you can use adapters to mount up to 3 SSDs based on the amount of SATA ports we have. Now, I had to use a dual Molex to PCIe power adapter, so I have 2 PCI 6 pins, and I'm going to mount a GTX 560 Ti Hawk in this case. So it requires a little bit of fighting with it because it's a very, very tight fit to get this card in here, but I think you guys are going to be very impressed with the gaming results we can achieve with this little tiny machine by doing this. So you guys can clearly see it is quite a tight fit. This system will not run cool and quiet, I'll tell you that much right now, but turning it around here so you guys can have a look. This is a pretty high-end freaking little gaming machine in this shuttle, and what I'm going to do is I'm going to run this, I'm going to boot this thing up, show you guys what kind of temperatures we get running a gaming benchmark. Now you can see here on the side, over here, the GTX 560 Ti does not have to rely on any front case exhaust for its air supply because there is an air supply directly next to it. So it should be able to intake reasonably cool air. The CPU is probably going to run a little bit toasty, but it's going to be exhausting that heat directly out the back of the case, and hopefully we can keep things under control. We haven't tried this off camera, so let's see how it goes. Okay guys, so we actually had to make a slight change to the configuration of our PC. I was not able to get it working with the GTX 560 Ti Hawk from MSI. So that's the card that I originally had in there. It just draws too much power. So the power supply in this barebones is a 250 watt at 50 degrees Celsius or 300 watt at 25 degrees Celsius rated 80 plus bronze unit. What that means is that we were triggering the overcurrent protection at around 310 watts with the temperatures as high as they were having a card like this inside. So we made a small change. We ended up going with a GTX 560 non-TI Twin Frozer 2. So this is a slightly less powerful card, but it also features an excellent cooler and very, very excellent DirectX 11 performance. So we've got that one in there now. Our max temperatures, we ran this before, but I have it running here in the background just to show you guys as a kind of final result thing. Yes, we can load this system right up. I've got it running Firmark as well as Prime 95 4 instances on the dual core CPU with hyperthreading. We are maxing out at about 285 to 290 watts from the wall. So given this is an 80 plus bronze power supply, it means we're pretty close to the maximum for the power supply, but it is doable, unlike with the GTX 560 Ti Hawk. So our max temperatures for our video card are going to be around 90 degrees, which is still within spec. So bear in mind, this is an absolute worst case scenario. In a more realistic scenario, you'd probably be looking at around 65 to 70 degree temperatures on your GPU and closer to about 250 watts out of the wall. So to finalize this video, I'm just going to show you guys a little bit of gaming footage. Alright guys, so I wanted to show you Crysis 2 gameplay footage, but unfortunately I've exceeded the number of activations that I'm allowed with my key, so I can't show you that. It's funny because I thought that was the whole point of Steam, that I don't have to deal with that anymore, but it's not. So here's Battlefield Bad Company 2. So you can see we're doing about 30 FPS, 29 right now, 28, 30, and that is even with explosions and fire and everything all over the screen. So this is a very, very respectable little gaming machine that you can put together for actually a pretty decent budget and in a very small form factor and in a very small power envelope. Very cool. I hope you guys enjoyed this episode on how to build your own Shuttle PC. Don't forget to subscribe to NCIX Tech Tips for more videos like this one.